If you've been keeping up with the latest astronomical discoveries or tracking modern space exploration efforts, you're probably aware of the monumental impact the James Webb Space Telescope, JWST, has had. One of its most striking achievements so far is the extraordinary view it has provided of Neptune, the icy blue planet lurking at the edge of our solar system. When NASA unveiled the first crystal-clear image of Neptune in September of last year, it caused waves of excitement across the scientific community and among space enthusiasts worldwide. This moment was significant as it marked the most detailed look at Neptune in over 3 decades. For the first time in a generation, researchers were able to glimpse parts of Neptune that had remained concealed in previous studies. Situated billions of kilometers from Earth, Neptune is a mysterious and remote world, often bypassed due to its formidable distance and inhospitable environment. However, JWST's sharper images have opened up a new chapter in our understanding of this enigmatic planet. To better appreciate Neptune's recent spotlight, let's review its cosmic context. It is the 8th and final official planet from the Sun, a title it retained after Pluto was demoted to dwarf planet status in 2006. With respect to size, Neptune is the 4th largest planet by diameter and the 3rd largest in terms of mass. In fact, it surpasses its near twin Uranus in mass and is also the densest of the outer planets, weighing in at around 17 times the mass of Earth. Neptune is not categorized as a gas giant like Jupiter or Saturn. Instead, it is known as an ice giant. This classification comes from the planet's composition, which consists largely of hydrogen and helium, along with heavier elements like methane, water, and ammonia. These compounds contribute to a turbulent atmosphere where frigid temperatures dominate the outer layers, and the interior may host scorching oceans composed of ammonia and water mixtures. It takes Neptune nearly 165 Earth years to complete one full orbit around the Sun, circling at an average distance of 4.5 billion kilometers. One of the most captivating aspects of Neptune's story is its discovery. Unlike other planets observed through telescopes, Neptune was first identified through calculations. In the 1800s, British mathematician John Couch Adams and French astronomer Urbain Le Verrier separately deduced the presence of an unknown planet influencing Uranus' orbit. Their predictions led German astronomer Johann Galle to observe Neptune for the first time in 1846, confirming the existence of this distant giant based solely on mathematical theories. The planet's brilliant blue color has long fascinated scientists and stargazers alike. The striking hue is caused by the methane present in Neptune's upper atmosphere, which absorbs red wavelengths of light while reflecting blue. This deep blue tone inspired astronomers to name the planet after the Roman god of the sea, Neptune. Yet, despite its allure, Neptune has remained one of the least studied planets in our solar system. Observations over the years have noted rapid shifts in atmospheric activity, with powerful storms and swift winds appearing and disappearing unpredictably. Our only close-up views of Neptune before JWST came from Voyager 2, which flew past the planet in 1989, over a decade after its launch. This brief encounter yielded a wealth of information, revealing a violent atmosphere teeming with fierce storms and supersonic winds that can reach up to 1,350 miles per hour, the fastest in our solar system. Voyager 2's data was groundbreaking at the time, and its images stood as the best we had for years. Even the Hubble Space Telescope struggled to match that level of clarity. That all changed in September 2022, when the James Webb Space Telescope delivered a stunning image of Neptune using its near-infrared camera, IRCam. The resulting view was unlike anything seen before. Instead of the familiar blue, Neptune appeared nearly black in JWST's image. This effect is due to methane's ability to absorb infrared and red light, giving the planet a ghostly and ominous appearance in the infrared spectrum. Despite this darkness, JWST revealed bright patches scattered across Neptune's disk. These luminous spots are actually methane ice clouds, which reflect sunlight and appear as radiant white streaks against the darker background. This level of detail has allowed scientists to track weather patterns and analyze Neptune's atmospheric composition with unprecedented precision. Perhaps the most exciting revelation from JWST's image is the detailed view of Neptune's rings. These rings, faint and narrow compared to Saturn's, were first discovered during Voyager 2's flyby, but had never been seen with such clarity until now. The high-resolution images from JWST captured the rings in their full elegance, showcasing their structure and enabling scientists to study them more thoroughly. One particular highlight in the image is a thin, bright line encircling Neptune's equator. Scientists believe this represents a zone of atmospheric circulation, revealing the planet's chaotic wind systems that churn across its upper atmosphere. JWST also managed to capture a familiar vortex near Neptune's south pole and a continuous band of clouds swirling at higher latitudes, providing valuable insight into the dynamic processes shaping Neptune's climate. The data provided by JWST is opening new avenues in Neptune research, enabling astronomers to scrutinize its atmospheric chemistry and cloud structures from millions of miles away. These findings reignite interest in Neptune's rings, offering potential clues about the planet's history and how such delicate structures have survived over time in a hostile environment. While NASA has launched dedicated missions to explore other gas and ice giants, such as the Galileo spacecraft, which spent years orbiting and studying Jupiter, and the highly successful Cassini mission that revealed the intricate beauty and complexity of Saturn and its moons, Neptune remains largely uncharted territory. Despite being one of the most intriguing and mysterious planets in our solar system, Neptune has never had a specialized spacecraft sent solely for its study. The only close-up observations came from Voyager 2's brief flyby in 1989, which offered a tantalizing glimpse but left countless questions unanswered. Now, with the extraordinary images and data provided by the James Webb Space Telescope, JWST, interest in Neptune is being reignited within the scientific community. These revelations have exposed Neptune's complex atmosphere, storm systems, and ring structures in greater detail than ever before, highlighting just how little we truly understand about this distant world. As a result, the push for a dedicated Neptune orbiter or probe is growing stronger. Scientists believe such a mission could revolutionize our understanding of ice giants, planetary formation, and even the outer reaches of our solar system. With mounting support from planetary scientists and space agencies worldwide, Neptune's turn in the spotlight may finally be approaching. One of the planet's most captivating atmospheric features, the Great Dark Spot, was observed during Voyager 2's brief visit. This colossal storm was similar in scale to Jupiter's Great Red Spot, large enough to span the entire Earth. However, unlike its Jovian counterpart, which has lasted for centuries, the Great Dark Spot mysteriously vanished when Hubble attempted to reobserve it in 1994. In subsequent years, new storm systems have emerged in Neptune's atmosphere, only to disappear again in relatively short periods. The transitory nature of these storms is unique and suggests that Neptune's atmospheric conditions are far more volatile than those of Jupiter or Saturn. It also raises questions about what may be happening beneath the clouds, where these storms might continue out of sight before resurfacing. One particularly notable event occurred in 2020, when a research team from the University of California, Berkeley, tracked a massive storm in Neptune's northern hemisphere using Hubble. Initially, the storm began drifting toward the equator, a region where storms usually weaken and vanish. However, this particular storm defied expectations and reversed course, heading back north. This unprecedented motion indicated that Neptune's atmospheric dynamics might operate under unknown or poorly understood mechanisms. Some of these storm systems have been as wide as 4,600 miles, showing the scale and intensity of Neptune's weather systems. These events underscore the importance of future close-range missions to study Neptune in greater depth. A dedicated orbiter, capable of continuously monitoring the planet's weather and probing its deeper atmospheric layers, would be invaluable. Scientists envision a spacecraft similar to the Cassini mission, one that could orbit Neptune, study its magnetic field, measure its atmospheric layers, and possibly even release a probe to descend into its swirling atmosphere. Such a mission would answer fundamental questions about Neptune's internal structure, its weather systems, and its evolution. Beyond Neptune's atmosphere lies another area of scientific intrigue, its moons. The most prominent of these is Triton, a massive and mysterious satellite that orbits in the opposite direction of Neptune's rotation, a clue that Triton is likely a captured object from the Kuiper Belt or another region beyond Neptune. Triton stands out for many reasons. It is geologically active despite its icy surface, with signs of cryovolcanism, volcanoes that erupt icy materials instead of molten rock. Voyager 2 observed plumes of nitrogen gas shooting kilometers into space, hinting that Triton's interior retains heat and possibly even a subsurface ocean. The surface of Triton is exceptionally smooth, suggesting recent geological resurfacing. Unlike many moons that are covered in impact craters, Triton's landscape is young and dynamic. Its thin atmosphere, composed mostly of nitrogen with traces of methane, is tenuous yet fascinating. This atmosphere is suspected to interact with seasonal temperature changes, triggering nitrogen geysers and potentially supporting complex climate cycles. One of the most compelling theories about Triton is that it may harbor an ocean beneath its frozen crust. If this is true, Triton joins the short list of extraterrestrial worlds, alongside Europa and Enceladus, that could potentially support microbial life. A mission capable of studying Triton in detail, including penetrating radar to look for underground oceans, would have profound implications for our understanding of life beyond Earth. Triton's capture by Neptune likely had major consequences for the rest of the planet's moons. Scientists believe the gravitational turmoil from Triton's arrival may have disrupted Neptune's original satellite system, destroying or ejecting earlier moons and leaving behind the irregular collection we observe today. Currently, Neptune is known to have 14 moons. Many of the smaller ones have eccentric, tilted, or elongated orbits, supporting the theory that Neptune has captured several objects over time. Among them, Nereid stands out for its bizarre orbit, which varies wildly in distance from Neptune, an unusual trait that further emphasizes the complex history of Neptune's moon system. The discoveries made so far have only deepened the mystery surrounding Neptune and its moons. But the advances made possible by the James Webb Space Telescope have brought us closer to answering some of the questions that have long puzzled astronomers. With each new image, JWST peels back layers of uncertainty, revealing the intricate, beautiful chaos of Neptune's weather, rings, and satellite system. It is clear that Neptune is not just a distant ice ball floating on the edge of the solar system, but a dynamic, evolving world with much to teach us. Still, to unlock its full story, humanity will eventually need to send a dedicated spacecraft, an orbiter, a lander, perhaps even a probe capable of diving into the clouds or scanning Triton's icy crust. Until then, we'll rely on our most powerful telescopes to bring us glimpses of this distant world. As we continue to study Neptune through the lens of JWST, we are witnessing a rebirth in outer planet exploration. These findings don't just expand our knowledge of Neptune. They help us better understand how planetary systems form, evolve, and potentially harbor life. In the end, Neptune is not merely the endpoint of our planetary neighborhood. It may well be the beginning of new discoveries that change how we see our place in the cosmos.